Hello, we are the hot metal workers from the University of Georgia, and this is our process video for creating an American felling axe for this year's FIERF forging competition. Here we're starting off by visiting our school's machine shop to cut down our initial 12-inch billet of stock 4140 alloy steel down to 5 inches. Our team doesn't have much forging experience, so this project was a great way for us to learn safe and basic forging practices. Forging started off with heating up our billet of 4140 for quite some time since it is a thick piece. We knew the billet would be ready when the steel turned bright yellow. Though not pictured, we compressed the billet lengthwise to make it easier for ourselves to create the axe head geometry. Our initial piece of steel wasn't very wide, and we felt as though it would be easiest for us to compress the piece to give us some allowance while punching the eye. Here you can see a more compressed piece of steel. We've now moved into punching the eye of the axe itself. We've marked where we wanted to punch the eye about 1.5 to 2 inches away from the edge of the billet. We knew going into forging that it would take extensive force and effort to actually create an eye, but it truly does take a lot to swing and hit accurately. When it felt too difficult to continue punching the eye, we'd return the billet back into the forge to heat up until it turned bright yellow again. Using an eye punch, we began driving through the heated steel, going about 3/4 of the way through before flipping the billet over and repeating the process. Flipping the steel over allowed us to meet the punch on the other side in the middle, making it easier as we began forming the full eye opening. Throughout our process, we ensured that one team member would hold the steel in place while the other one forged. We learned a lot about forging in general while we took turns, becoming more consistent and comfortable forging as we finished up with punching the eye. After the initial eye hole was created, we moved on to using a drift to expand and shape the eye to fit our handle. This step required precise and careful control because overexpanding could weaken our structure while underexpanding wouldn't fit the handle into the axe head. During this stage, we ran into one of our biggest challenges yet. A drift got stuck inside the eye of the axe. Because the steel cooled faster than expected around the drift, the eye locked the drift into place and we were facing difficulties trying to remove it. Typically, we wiggled the drift out of the axe head by holding the head down, but this time around it was far more complicated. You'll also notice that we frequently dip our tongs and other forging equipment into the quench bucket, and that's so that we can cool them safely before we continue forging. To fix the issue, we ended up placing the entire axe head back into the forge along with the drift that was stuck inside of it, reheated it, and hammered the drift back out. It took several heating cycles and lots of persistence, but we were finally able to remove the drift and continue on with the forging process. Now that our eye hole was properly formed, we shifted our focus towards shaping the blade itself. We used the cross-peen end of a hammer to spread the steel outward, creating the shape for the edge and using the face side to flatten out the ridges in the steel. This step was repeated through multiple heat cycles to gradually refine the geometry rather than trying to achieve the shape in a single pass. As the blade was starting to take shape, we periodically checked the eye during this process since it became slightly deformed from the hammering, causing it to shrink just slightly. We were able to fix the minimal deformation in our eye shape quickly by redrifting it. Here you can also see us continuing to flatten out the cutting edge of the axe head itself. Now that the axe head was forged, we moved on to grinding the cutting edge, making it a true felling axe. We filed the steel down precisely to create a well-sharpened, strong edge. Our heat treatment process for ensuring toughness, hardness, and overall strength was fairly simple. First, we heated the axe head to about 1400 degrees Fahrenheit and then quenched immediately in mineral oil preheated to 120 degrees Fahrenheit. After that first round of oil quenching, we put the axe head back in the forge, heated to about 200 degrees Fahrenheit to maximize its strength. Now that the axe head was fully finalized, we moved on to our axe handle made out of ash wood. Its shape is simple and was created using a draw knife and whittling knife. We secured the axe head onto the handle using wood glue, ensuring a tight initial fit. Then using a mallet, we carefully hammered the two pieces together, allowing for the axe head to sit firmly in place, creating a durable connection. Thank you so much for watching and giving us the opportunity to forge with FIERF this year. We'd like to thank our faculty advisor, Dr. Pagan, for his immense and continuous support, as well as Triton Forging Company for sponsoring us and serving as our forging partner this year.